Just a warm welcome to everybody. Baie welkom. Dankie julle ingeskakel het en deel maak van vanaand se tegniese aanbieding. And Oliver, thank you for being willing and able to do the research and the presentation. We appreciate it. As you most probably know, Oliver is going to do a presentation on the magnetizing of the Model T ports magnets. Different ways of doing it. Okay, Oliver, over to you.
Thanks. So, good evening, everyone. Tonight we're going to talk about the Model T magnets and how to magnetize them. And we're also going to talk a little bit about the magneto, or what should really be called the alternator, and the actual complete system. So just to start off with, I'm going to go through a tiny bit of history and a little bit of technical information. So the first thing about electromagnetism is that when you have a coil and you pass electricity through it, you get an electromagnet. And this particular phenomenon was discovered by a gentleman called Ørsted. And it's known as Ørsted's law, and it's pretty much the basis of our entire modern world when it comes to electromagnetism and electromagnetic theory. So Ørsted's law states that a steady electric current creates a magnetic field around the wire through which it flows. And this discovery was made by Ørsted in 1820, and was, excuse me, I've paged one page too far already, and was the first direct link established between electricity and magnetism. And this laid the foundation for electromagnetism, and his key principles enabled people like the Danish physicist, Michael Faraday and Ampere to experiment and pretty much put together enough so that a very famous Scottish mathematician called James Clerk Maxwell came up with a complete theory of electromagnetic wave theory, and these equations are known as Maxwell's equations. And I think that's enough basic history there. It's also pretty much basic school physics, so we don't need to harp on that too long. But basically, it tells you that current makes an electromagnet. So let's go on to page 2. And that is the theory of hysteresis. The theory of hysteresis is that metals, and basically only 3 metals on the periodic table, and then some mixtures using rare earth, will make a magnet, and that is iron, cobalt, and nickel. These 3 elements are electromagnetic and portray magnetic properties. And if you have a look at this curve, you can see that if you have a very hard steel, it has a large hysteresis curve, and if you have soft iron, it has a small hysteresis curve. And on this field, you have B and the H. The one is the magnetic field, and the other one is the flux. And basically, what it's really telling us is that if we magnetize a metal in a magnetic field, the soft metal will lose its magnetism and the hard metal will retain its magnetism. However, it also tells us that it's harder to magnetize the hard metal, and the soft metal will magnetize quite easily while in the electric field. But when the electric field or the magnetic field is removed, it won't retain its magnetism, And basically, it's just walking us through the very basics. And we really don't have to know much about this for the purposes of our Model T magnets. Just a little bit of basic theory here so that you can have an understanding of what's actually happening. But it's just there for the purposes of completeness. And so what we find is that magnetic materials have magnetic domains, and they're completely at random when the material is not magnetized. And by applying a strong magnetic field, we can make these domains orientate themselves. And in a metal with a high hysteresis, when the magnetic field disappears, these magnetic domains remain aligned, and the material then shows magnetic properties and it acts like a magnet. And the reason why this is mentioned here and important is later on we're going to discuss recipes on how to make a magnetizer. And there's some simple rules which one has to bear in mind, but we're not going to go into the theory of turns ratio and this and that. We're just going to apply the basic rules so that we achieve optimum results without actually having to do any real hard maths. And please, this presentation is going to be available for everyone to download, so that once we finish this talk, you can go through this, you can read through it, and then you have a basic understanding of what you need to do to magnetize magnets and to actually build your own magnetizer. So we've discussed the soft and hard magnetic materials. We have the basic theory on hysteresis, and we've done that. Now, what are the minimum requirements that we need to make a magnetizer or magnetize T magnets? And the minimum requirements are a compass, a power source, such as a 12-volt car battery, a fairly large one with a low internal resistance, some terminals to put on this battery so that you can protect the battery terminals themselves, cables to handle the current, or alternatively, a DC arc welder. And so even the cheapest DC arc welders are able of giving you about 160 amps, and they start with a high voltage, which collapses very fast. But with a DC arc welder, we just need the current. And the current, as we'll see a little later, is the most important part, because if we can put a lot of current through, we get a fairly high ampere turns number. And then finally, we need a magnetizer. And that's a unit that you either borrow or buy if necessary, or if you really must, you can cobble one together, but and we'll explain that a little later. So all this information is freely available. You can have a look on the internet. I use the Dykes Automotive Encyclopedia, or Automobile Encyclopedia. And I've owned the Dykes since I was very young, probably 12 years old. And I still refer to it every day, and even for instructions on Model Ts, it's adequate and very sufficient. So I've put the 2 pages of which this evening's read is basically about here in the presentation. And when you download this presentation, you can either zoom in on them or read the presentation. I've taken 90% of what I present here tonight from these 2 pages of Dykes, and I've just simplified it and made it relevant for us in the modern world. So as I said, you need a compass, and the compass is to check the polarity of the magnet. Next picture, please. You're going to need to, once you've magnetized your magnets, to actually keep them magnetized before you reassemble. And one method is to put them pole to pole, so north to south and south to north. Or the other method is to put something called a keeper across the magnet, which is just a piece of soft iron that completes the magnetic path. Next picture, please. You're going to need a weight, ideally of 2.2 pounds, but I don't have 2.2 pounds. So I taped two 1 pound weights together, and it looks like this. Next picture, please. Here's a picture of the terminals. You can see that you can get the terminal pretty burnt if you don't protect it. So it's just a close-up of the terminal I use, and actually of the battery terminal, which has in the past had quite a few burns on it. That's the size of the battery that I use. Next picture, please. Okay, and so here we come to remagnetizing magnetomagnets. Now, this is a general recipe from Dykes, and it's how to remagnetize Model T magnets and magnetomagnets, proper magnetos, on a magnetizer. And there's a picture of a magnetizer there, and we just quickly go through the basic instruction. So the device that's shown here in this picture is an electromagnet designed to remagnetize the permanent magnets which are used on magnetos. And this is a recipe on how to remagnetize your magnets once your flywheel has been disassembled and you have the loose magnets in your hand. And so you need a fully charged 12-volt storage battery to be connected to the terminals of the magnetizer. As I said, you need heavy wires. A really good pair of jumper cables is ideal. On closing the switch on the base of the device, a current of 20 to 30 amps will flow. And this is dependent on the internal resistance of your battery and also on the resistance of the magnetizer. But if you build your magnetizer right, this is more or less the current flow you should get. And then the magnetizer becomes a powerful magnet of such strength that the magnet placed across its poles will be magnetized to its maximum strength. And then you have the picture of the magnetizer. Next, and in order to properly remagnetize magnetomagnets, it's necessary to remove the magnet from the magneto or from your Model T before doing so. One side of the magneto, that is the pole piece, and the legs of the magnets on the other side. So you need to mark the magnets, and you should short mark them so that you can get them back together how they go on a magneto. But this is a general description for magnetos and Model T magnets. So we can ignore the part for the magneto unless we have a car that uses a magneto. So the pole pieces and the legs of the magnets, okay, should be chalk marked. And we mark them with compass so that we can do this in fairly short order and not make a mistake when we put it back together. And also, it's a good idea to mark your magnets beforehand so that you can do them all in one shot. You don't have to measure them with a compass every time you put them on the magnetizer. And then the next picture that we see is the picture of a magnetomagnet on the magnetizer and a picture of a Ford magnet on the magnetizer. And you'll see on the Ford magnet, they've actually put special pole pieces on the magneto so that they minimize the air gap. And this is actually a very important, and most of us don't do this. I'm fortunate to have access to a magnetizer that is so strong that it overcomes the air gap. But for absolute maximum efficiency and the best working procedure, you actually need to make those little angle pieces so that a Ford magnet will sit properly on a magnetizer without any air gap. And true to form, in the 1900s, at the beginning of the last century, we didn't just use storage batteries, and most storage batteries were 6-volt. Today we'll just use a 12-volt battery. They also had the ability to use igniter cells or 1.5-volt cells. You could buy them fairly cheaply, and they would string them together, and that was enough to give you the current to magnetize on your magnetizer. So the magnets are placed 1 unit or section at a time, and that spans the poles of the magnetizer as shown in Fig 7, and the switch on the current is switched on and off several times. And the current need only flow for a few seconds at a time. While the current is flowing, the permanent magnets to be charged should be wrapped a few times. And I would use a brass hammer, but if you don't have a brass hammer, a wooden mallet would be fine. But don't use something magnetic. A, it interrupts the magnetic field, and B, you'll find it sticks quite hard to the magnet, and it's hard to tap the magnet several times once the hammer's stuck to it. And the reason for the tapping is to let the little microscopic domains move within the metal structure and align themselves with the field. And as it says here, this will assist the magnet to absorb the magnetism easier. It is well to place a piece of soft iron across the poles of the magnet before removing it. So once you've magnetized it, you put the keeper right next to it, and you slide it over the end of the magnet, or you take another magnet and you slide the two together, north to south and south to north. And then you can leave them lying in the workshop like that until you're ready to use them.
Oliver, just a question. If I understand you correctly, you leave them lying with the keeper on.
Yes.
Okay.
So a magnet that is open-ended will demagnetize much faster than a magnet with a keeper on it, or a pair of magnets that are north to south.
Okay, thanks.
And it's got to do with the magnetic circuit. Okay, so we've talked about the soft iron keeper. And then they say, make sure that it's put back together exactly the same as we took it apart. And they also say, do it in the shortest time possible, because this will allow the, if you leave the battery on too long, it will drain the battery. I've never really had that problem. It's fairly easy for us nowadays just to take a break and charge our battery and start all over again. Okay, there it says it's possible to dry cells. Okay. All right, so we've basically talked through it. I've summarized what's written there, and when you want to do your magnets, take this presentation, go through it quickly, and you should be ready. So this was a recipe on how to do your magnets once you've got them loose and in hand. However, lots of us want to do our magnets while they're still in the car. And there are, okay, so let's just go through, there's some pictures here of the magnetizer that I have access to. So this is a magnetizer. This is an original Bosch magnetizer from the period. And it's designed to remagnetize magnetos, not just magnets. And the idea was that you could put the entire magneto in there and magnetize it, and it's adjustable. We need to magnetize our magnets in the correct polarity, and the magnet will have a north and a south. When the north pole on the compass is usually marked red, and the south pole is usually marked white. The north pole of your magnet will attract the south pole of your compass. So here I can see that my south pole is attracting the north pole, and if I turn this over, I can see my north pole is attracting the south pole. And I have to pair the north pole to the south pole, or alternatively the south pole to the north pole on the magnetizer. So the magnetizer is marked, and I'm putting the south pole on the north pole. So now I'm going to apply voltage to the magnetizer. I have a car battery set up here with terminals on it so that I don't damage the terminals of the battery. And as you'll see, you get an arc. So I'm going to leave the battery connected, and now I'm going to tap the magnet with a copper hammer. And I'm tapping it quite hard. This is to allow the domains in the magnet to reset and become polarized. Now I'm going to collapse the field several times to get the magnet to its maximum available strength. Because it's on the collapsing field normally that you get the maximum magnetization. Now we should have a fairly well magnetized magnet. And now we're done. There you see a picture of my magnetizer. Oh, it's not really mine, but I have it in permanent loan in my garage. And the battery, and you hit that battery with your battery terminal, or you throw the switch several times, and you'll see a fairly large arc. Now that arc or spark is due to the inductance of the magnetizer. And something called Lenz's law, the current wants to carry on flowing in the inductance after you remove the voltage. And there's a bit of a controversy. Some people say that you magnetize on the rising field, and some say it's on the collapsing field. And it's not that straightforward. When you put voltage across an inductor, the inductor contains capacitance, and it's an oscillatory rise and also an oscillatory fall. The current doesn't just flow smoothly. And real magnetic theory, if you look very carefully into it, the alignment takes place during those spikes in oscillation, the big peaks or the big falls. So you only need to do it very shortly, but you do need to do it repetitively. And depending on your magnetizer, if it's a very good one, you only have to hit it about 10 times. And if you build a homemade one, you may have to hit it 30 times. But we'll get to that later. So now the next thing is we're going to talk about how to do the Model T magnets while they're still assembled in the Model T. And this is the second page of the dikes. And here we have remagnetizing Ford magnets. Give me 1 second to get there. So when you remagnetize Ford magnets on the Model T, you need access to the magnets. So when it says here remagnetizing Ford magnets, the preferred method is obviously to replace the magnets. That's what they said in the 20s when you could go to any Ford store and buy new ones. However, we can't do that, and we don't want to disassemble our motors. So the method to do this is to actually remove what they call the transmission cover, and we would call the hogshead. You can distinctly see that this is a fairly small magnetizer. Fit the Model T magnet while you have access to it when the hogshead is removed. And again, it's the same thing. It's an electromagnetic circuit. It's 2 large coils on either soft steel or laminations to complete the magnetic circuit. And it's got those special little adapters to fit the Model T magnet. And the premises is that you take this magnetizer, you hold it onto the coil, onto the magnet, and you need to pair them north to south. You give it a hit, a couple of hits with your magnetizer connected to the battery until the magnet is fairly strongly magnetized, and then do the next one. But remember, alternate, so you have to turn the whole assembly around and do it from the other side. It's basically two larger electromagnets. It's just, and it's you can't see a huge physical difference in the picture. It's just a line drawing, but it's small enough that you can hold it onto the magnet while the hogshead is off. Okay, so I'm just going to go down and read the rest of that page. So it says here, mark the south pole of the remagnetizer and mark the poles of your magnets, and then make sure that you remagnetize them in the correct order, turning the flywheel between magnets, and you remagnetize them one at a time, and afterwards verify your polarities using a compass. It's not that difficult to flip a magnet and to repolarize it in the wrong direction. And it's really not that difficult to correct it afterwards either. It just takes a lot more hits on your magnetizer. And then there's a final method. And this method, I really don't recommend this method. It does work. You will, if you're on YouTube, find videos of guys doing it. It's already mentioned in the dikes. It is sort of semi-Ford approved by the looks of it, but with our old magnetos and the solder connections being poor and the insulation being poor, the chances are that you're going to damage your magneto coil, either short it to ground or make it open circuit. Anyway, this is the method. So you have to, and this is now with the car fully assembled, nothing taken off. You access the top of the hogshead, and you disconnect the meter from the magneto from the hogshead. So there's the hogshead. You disconnect the cable from there. Let's go through the pictures quickly. Next picture. Okay, there you'll see I've made a mark. So you make a mark 1 inch to the left and 1 inch down from the magneto terminal. Next picture. There I'm measuring it, showing 1 inch. And there you see I've aligned the north pole carefully by cranking it over, and the compass is fairly sensitive, and it's very difficult to actually get a perfect alignment because the magnets are close together, and you know, the compression of the motor, even if you've got the spark plugs removed and the drag of the gearbox, it's very, very difficult to get a perfect alignment. But there you go, I managed to get it. Next picture. Right there, I'm just about to mark it. Next picture. Okay, here, yeah, next picture. We've already had that one. Where are we? No. All right, let's just go down. So what you do is once you've removed the cable, if you've aligned it up according to recipe, you need 6 6-volt storage batteries or 3 12-volt storage batteries in series. So that's 36 volts. And that's the minimum. I've seen people recommend as much as 48, and I wouldn't go there. I think if you really want to do this, do it with 36 volts. So you disconnect the wire from the dash coil. You've aligned your flywheel, and you have made the mark on the hogshead, and you are now ready to bet your life on the soundness of your magneto coil. So if you have a freshly rebuilt magneto coil, and if it's installed correctly, I guess this is something we can try. But if you've got an old magneto coil, or if you've got a rebuilt magneto coil and you're actually not sure whether you've got the North Pole or the South Pole at the top, then I recommend don't do it. Anyway, you connect the battery and then you hit it 30 times. And be very careful not to get it to connect permanently. You will melt the wire and you will also create other damage. Okay, and that's the 3 methods of doing Model T magnets. Okay, so let's go through some of the pictures and some of the videos.
Just a quick question while he's looking for that, Oliver. the position where you're actually attaching your wires to, or your coils to, is that the terminal of the magneto post?
Correct. You hit that magneto post. So what you're doing is you're using the coils of the magneto to set up the magnetic field. You have a very small gap. It's between 25 and 40 thou. That strong magnetic field that the coils will set up will, if it's correctly aligned, magnetize your magnets.
Where do you attach the second terminal
the
of
ground? The ground.
Okay.
Okay, so one of the things we'd like to do when we test our magnets is also make sure they're not cracked. If a magnet doesn't hold its magnetism, make sure that it's not cracked. And normally if they're cracked, they'll fall apart, but you could theoretically crack test them and have the magniflux, but you can also hear when a magnet has a crack. Hang it over a thin piece of wire and tap it with a plastic screwdriver handle, and it'll ring. And if it rings with a clear tone, it's not cracked, and if it rings with a dull tone, it's cracked. And a cracked magnet will not hold a magnetic field, not for long anyway, and it'll always be weak. And once you've finished magnetizing your magnets, check them. Minimum 2 pounds that they can pick up. If you can pick up 4 pounds, I believe that a well-magnetized magnet can pick up as much as 9 pounds. And then let's get on to building a magnetizer. So when we want to build a magnetizer, we need to understand some very basic principles. A magnetizer, when you plan it, you plan the ampere turns for the magnetizer. It involves calculating the necessary magnetomotive force, and this is fairly simple. It's the current times the turns. And I wouldn't bother about working it out. You build it as large and as heavy as you can, and then afterwards hit it with the most current you can, and you will get a fairly well magnetized magnet. But I've just gone through the basics that this involves. So to achieve the flux density, you need to consider the cause material. So a good soft iron, an old transformer will do fine. And then, and the reason for that is that the field collapses and rises very fast on the soft iron or an old transformer, which is designed to do. And then the geometry, the larger the metal core that you use, the stronger the magnetic field you're going to generate. And then the maximum amount of turns you can get on there with the thinnest amount of wire will build your best magnetizer. So the key steps to plan is obviously we define the requirements, we calculate the magnetomotive force. We're not going to do that. We're just going to take examples from real life but if you wanted to, this is what you do. So calculate the magnetomotive force. It's the number of turns and the current through them. And then the material, I've explained, a soft iron of the largest diameter that you can find. Obviously, don't make it much bigger than the magnet, but at least as big as the magnet pole face, somewhere about 30 to 40 millimeters diameter mild steel rod would be ideal. Okay, minimize the air gaps. I explained the flux density drops off very quickly in an air gap, and if you can minimize the air gap, you have the best chance of magnetization. And then just to give you an idea, if you have 100 turns at 10 amps, you have a flux density 80 of 1,000. If you drop your current to 2 amps, you would need 500 turns. And to get 2 amps to flow through 500 turns, you'd need a fairly thick wire. And then it becomes expensive. And with our access to really big car batteries or even better DC arc welders, we don't have to worry about this too much. So the conclusion, is with a car battery, you'll probably get about 30 amps. And with a DC arc welder, you probably get somewhere between 160 and 200 if you really want. But from 60 amps to 100 amps would be more than adequate. Okay, so let's have a look at some of those magnetizers and pictures that we've got of magnetizers.
Vintage Bosch magnetizer from the 20s that used magnetizing magneto magnets and
so if you have a look at this Bosch magnetizer we've just looked at, okay, there are 400 turns on each pole face. There's 4 layers of 50 turns, sorry, 200 turns on each pole face. There's 4 layers of 50 turns on each side, so that's 400 turns. And it's a huge soft iron lamination, and that thing will saturate pretty much anything you put on there. Why don't you show me the one with the orange wire, please? Okay, let's stop there for a second. So this is a magnetizer that's been built by Sean Painter. He's got pretty much 30 turns on each side there. It's 2.5 millimeter square household electrical wire. He's used a drive shaft from a Ford that he's cut to size and a piece of I-beam. And he's dimensioned it so that it fits the magnet well. And he drives that between 60 and 100 amps with his DC arc welder. He's probably achieving 160 amp surge current, if not 200. And he says with a couple of good hits, he gets fairly good magnetization with that. And something that's that small, where the pole faces have been filed so that they fit nicely on the Model T, would quite easily do the magnetization inside the hogshead. I would still write the north and the south on there, and also write and clearly mark which terminal which end of which wire goes where. Okay, let's have another picture. Okay, so the second picture here shows a magnetizer that was built by Ockett. And this is a really well-designed magnetizer. He's taken an old transformer, he's cut out the center core and used the bobbins from this transformer or other bobbins from a transformer to wind his coils. And he's put them in north and south. And I think he's taken the eyepiece of that transformer and made pole pieces for the top. And the whole thing can be held together with glue, super glue, epoxy, minimizing the air gaps. And we have a bigger picture of this, please, Philip.
I don't think I've got a bigger one.
And oh, you've put them in pairs. Okay, so there's the same magnetizer that Orchid's built. And on that magnetizer, he shows the magnets for size. And this is a really well-designed piece of kit. And if you can see on the diagram or on the magnetizer, he's shown that he uses 60 amps with it. And it's a thick piece of wire on I guess, a 2 kVA transformer that's been modified. And that's a very suitable steel. The laminations magnetize very quickly, and the field collapses very quickly. It'll help you magnetize your magnets really quite well. And the second piece of kit that we're showing here is related to the whole issue of the magneto alternator in a Ford Model T. This is something that Kevin built, and it's a meter that you put on your running car to show whether your not your running car, sorry. This is a meter that you put on your magneto terminal to ground. And if you spin your car up without the magnets in it and the wheels off the ground, you'll get a reading on there. It's calibrated for the early magnetos and the later magnetos. Next picture, please. And this is basically what's inside there. It's the primary coil of a Model T coil, connected up as an inductor in series with a 5 amp DC current amp, a 5 amp AC current ammeter. And this actually makes perfect sense because our magneto has to fire the coils and it has to be connected across the magneto as the timer moves around. That primary coil is connected directly between magneto and ground every time it fires on a spark plug. So that is the load that your magneto is going to see. Kevin has turned off a couple of turns on the primary winding of the coil, basically to calibrate it. Basically because this is done at hand speed. Once you've assembled your magneto and you've got it assembled, you can spin it up by hand, put this across it, and you can see it. Or alternatively, if you've got your car, you can put this across and spin your car by hand, and it'll show on the scale in the front. It took me a while to get my head around this. At first, I thought that was the inductor, but in actual fact, that's the inductive load that the car is going to see when it's driving the coils. So that's the ideal load. And the 5 amp AC ammeter is basically a short to ground. So you're just loading your car up with the load that it sees in the normal operation.
Oliver, we tested it. You can put it on a car while running as well. It will show you the magneto is good or bad. It's basically a go, no-go meter.
But that's correct. I spoke to Kevin as well, and he said you can put this on your car once you've assembled it at the magneto and just spin it up by hand. It'll show already.
Yes, but you can't leave it on the car while running for a long time.
No, you can't leave it on the car while running. It'll kill the car. Yeah.
Yeah, as well as the coil, because you can't cool it.
Yeah, sure. Okay, thanks, Orchid. Right, and so now, any questions?
John, it's Viv here. Can you hear me?
Yes, Viv, how are you? Good evening. I heard you earlier, I heard your voice.
Yeah, well, it's quite interesting because I didn't know any of this rather complex stuff, and I looked on the internet. And what I did, I got a whole lot, nice long length of house wire. I took the actual magnet. I wound it the one way around the one side and the other way around the other side. And I got a 12-volt car battery. And I put my 4-pound hammer on the bench. And I did 10 or 15 sparks on the car battery, and it picked up the 4-pound hammer. And it was simple as that.
I'm sure it will. And that is an alternative. You don't actually have to make a huge magnetizer, but remember, Viv, you had your magnet in your hand, and we wanted also to have a method of doing it while the magnet's still in the car.
Well, I did that as well with the arc welding Riddy and Phillips machine to do that. I did that on another car.
Correct. Yes,
but
correct.
But with a 4-pound hammer, if it picks up the 4 pounds, you've got it right, haven't you?
Oh, definitely. 4 pounds is adequate. As I say, I believe if you magnetize it really well, these magnets will lift up to 9 pounds.
Yeah, but that 4 is enough, and that thing took me all of 10 minutes to make.
Yes. So Ford recommended, or the recommendation is that it picks up a Model T piston, and that is 2.2 pounds.
Okay. Anyway, there it was. That's what I did, and it seems to have worked quite well.
So definitely a method of magnetizing the coils would be to wind the coil directly onto the magnet, and ideally you would put a keeper across the front to complete the circuit.
Well, yeah, I didn't do that, but I assembled it straight away after that.
Yes, I'm sure you assembled it. But if you put the keeper across the front of the magnet, you'll complete the magnetic circuit and actually increase the flux.
No, I don't argue with that. I should have probably done that, but I didn't.
Yeah.
But it's working,
yes,
okay.
there are recipes for that as well. There's many ways to do this. I can also explain how professional magnetizers work. They actually work on a slightly different basis. I was involved in making a magnetizer and magnetizing speaker magnets. speaker magnets are made from ferrite, and they come unmagnetized, and then they're assembled onto their pole pieces. And the way these are magnetized is, again, you just have a coil. You don't have any metal parts. But they do complete the circuit with a soft iron keeper. And then they charge a capacitor bank. And these are large AC capacitors, the oil-filled type that are used for power factor correction, where one capacitor will kill you. And they'll have an entire bank of these capacitors. They'll charge them up with a DC power supply. It doesn't have to be a very stiff DC power supply, only a couple of amps and through a large resistor. And when the voltage is obtained, there's a big contactor and one big bang, and everything jumped around. And there's a huge amount of magnetism in the ferrite. The magnetism is initially so intense that it's basically got the saturated air gap, and it falls off within a couple of days. But we're talking about, I think it's 70 kilogauss or 7 Tesla in the air gap, which is fairly intense.
Yeah, but what I found, the key thing was enough strikes.
Yes.
So
as your magnetizer becomes smaller, it's the way to compensate is to strike more.
yeah, the simple solution was the insulation. When it was magnetized properly, the insulation was just melting on the wire.
Yes, Sean says the same thing. He says when he can smell the PVC, he knows these magnets ready.
That was exactly what I discovered.
Yes.
Okay,
Any other questions?
Any other questions? Nog iemand enige vrae daar vir Oliver?
Just another little thing, not Model T, but I've got the Talbot Dirac and I've got the Sunbeam, and they both got magnetos, and we were lucky to get a proper magnetizer for those, and pretty well what you described. We used that procedure and for those
yes,
ones.
so the magnetizer that I have access to is actually a Bosch magnetizer designed to magnetize Bosch magnetos. It has special machined pole pieces that fit onto the pole at the top, and it's adjustable so that the circuit is complete. And you can actually magnetize the magneto without taking it apart. You do have to make sure that the magneto is in the correct position so that it's able to spark.
Yeah, the first one we did it the wrong way around, unfortunately. So we had to do it all over again.
and then you have to run your car backwards.
Yeah, exactly.
Yeah, and it's not a joke. If you do it the wrong way around, the magneto will still spark, but it's going in the wrong direction.
No, it's exactly what happened with the famous Lynn Ward here in Cape Town. He did it back to front for me.
Yes, and that's because lots of people don't realize that you have to put the north to the south. If you put the south on the south, you repolarize it and you end up with the north on the wrong side.
Exactly that.
Dankie Oliver. Nog vrae daar vir Oliver, enige iemand?